6.5 RSG. I'm going to just briefly talk about the ready. It's not something that is super important, but it does make sure you understand the area and circumference of a circle and how you can use the radius and the diameter and the circumference to find different things out about a circle and maybe wear and tear on a actual physical object. So here we're going to be talking about wheels on a wagon, and think of a old-time wagon where maybe it does have the littler wheels in the front so you can step up onto whatever the wagon is, and then it's built with bigger wheels in the back. So I suck at drawing. So something like this, let's draw a bigger wheel. And you're going to be finding out some information. So you have to pay attention to the front wheel having 12 spokes and 44 inches from the ground. So a spoke, if I have a circle here, a spoke goes from the center out to the circle. So it's like a radius. So there are 12 of them on the front wheel, and they are all evenly spaced. Spokes are evenly spaced throughout that circle. And then it's 44 inches from the ground. So from here to here is 44 inches. And then the back wheel, which you can set up on your own, the rear wheel has 16 spikes and is 59 inches from the ground. Then you're going to use that information to answer the rest of the questions in the ready. So area, remember, is pi r squared. Circumference is 2 pi times the radius, or diameter times pi. Find that for each of them. Then you're going to find the central angle. Central angle is whatever the theta is between each spoke. So think about how you could find that. Find the distance on the circumference between two consecutive spokes. So going back up to your picture, you're finding this part. So it's the distance on the circumference. So think, okay, I'm going to need circumference, and then you only want one piece. So what do you need to do to find that? And then on 4 and 5, you're actually looking at the rotation of the wheels. So for number 4, you will need to convert because your radius is in inches. So when you're finding circumference, you're actually finding it in inches, but here they want how much distance are you covering in 15 miles. So they're going 15 miles a day, and it wants the revolutions of each wheel. How many times does that wheel revolve every day? So miles, just so you know, 1 mile equals 5,280 feet. And then you need to know that 1 foot has 12 inches. So you will need to use some conversion skills here. All right. And then you guys can work on 5. Now let's move on to the set. So here, the set, we've already talked about that cosine. Let me get rid of that. That cosine is x over r. And this is the same thing as x squared plus y squared equals r squared. They've just square rooted to get r by itself. I like you using x squared plus y squared equals r squared, just so you have practice using that formula in its true form of the Pythagorean theorem. And then you guys can square root. So you had these same 4 triangles in a previous homework where you were finding sine. So just remember, your ordered pairs are x, y, and then you're going to plug in to find r. Then you guys can go through and find theta. So this is wanting you to, just find cosine. You're not finding theta yet. So you're just finding cosine. So x over r, but you have to find r first. Not going to go over that with you. You guys should be able to do this just fine. So 10. In each graph, the angle of rotation is indicated by an arc and theta. Describe the angles of rotation that make the x value of the points be positive and the angles of rotation that make the x values be negative. I would really just like you to find the angles of rotation here, find theta. This is really where is x positive and where is x negative. So looking at the quadrants, what angle measures. So for example, 0 to 90. So it has to be greater than 0 and less than 90 for it to be positive. So you can answer it that way. You're just saying between what angles, pay attention to the quadrants. You can tell me quadrant 1, 2, 3, 4 is fine. And let's see, what do you notice about the x values and the value of cosine in the graph? So find some connections there. On number 12, I would like you to use your unit circle. So read the directions and then use the unit circle to help you answer those. And just as maybe a bonus, find sine also. Now you're solving triangles. So we're going back to solving right triangles. So please remember, because we did not go over special right triangles. So if you know the 45, 45, 90 and the 30, 60, 90 triangle shortcuts, you are welcome to use those. We did not go over that. We stuck with SOHCAHTOA. We used right triangle trigonometry and the Pythagorean theorem to solve all right triangles, special or not. One less thing to have to worry about memorizing. So remember, sine is your opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And that will help you find angle measures, even some missing sides. And then remember Pythagorean theorem, a squared plus b squared equals c squared. So all these are right triangles. You have a lot of these. All of these are right triangles. You can use some shortcuts here. It tells you C is the right angle. Remember, these mean that they are the same length. So I would know that this is 5. You should be able to find the angle measures super easy. If you know 90 degrees is taken by the right angle, you have 90 degrees here. And since those two sides are equal, the angles are equal. So it should be quick, and then you can use the Pythagorean theorem. On the flip side with 15, when you use the Pythagorean theorem, if this is x, this is x. Or let's use a. If this is a, this is a. So now you can use the Pythagorean theorem. Shouldn't be too bad. Back or down on these ones, same thing. C is the right angle. You should be able to find the missing angle measure. Now, you can go through and use SOHCAHTOA to find the other two angle measures. If this is the side you're looking for, side B, use one of these angles as a reference, the 30 or the 60. This is your hypotenuse. This is your opposite, so you would use sine. So just a refresher, sine of 30 equals opposite over adjacent, which is 14. Now, to make your life easier, sine of 30 is on your unit circle. Take the time, get out your unit circle, find the sine of 30. We've gone over this. You should know what the sine of 30 degrees is. And then now you're not having to use your calculator. You can actually use your brain. Sine of 30 is going to be 1/2 equals opposite over 14. And now you're just looking to find the opposite. So I'm going to multiply both sides by 14. And 14 times 1/2 is 7. So the opposite equals 7. So this side is 7. Now you can use the Pythagorean theorem. And you can say, let's call that a. A squared plus 7 squared equals 14 squared. And then you might find some shortcuts to help make this easier for you as you guys are working through this. Use your unit circle if you want to. You're welcome to use your calculator, but remember, I don't want decimal answers, so you might want to use your unit circle. And then you guys can just use that to answer the rest of those. And then on 23, 24, and 25, it's just getting you guys to realize pi is just a number. You can use 3.14 for this if you want, but you can also use your calculator. But if you don't have that readily available, you can use 3.14. All right, that wraps up the sorry, I don't know why I said 3, probably because the pi 3.14, but this will wrap up the 6.5 RSG video. Please have questions ready for our homework question day.